Let's get started. We're moving right along in Unit 7. I'm going to complete A, B, and C without talking, and then I'll start explaining the challenge question starting now. All right, there's A, B, and C without talking. Now, let's jump to the challenge question. The challenge question is a little bit tricky. However, this challenge question is actually a fifth grade Common Core. I'm trying to sneak it in a little bit to give you guys a little bit of practice because students really struggle with this, right? Now, this is called finding the area of an irregular figure. Now, what's cool about this irregular figure is if you use a little bit of an imagination, you could turn it into two different regular or normal figures. How? Well, if I put a line right here, do you see how it's a rectangle and a rectangle? Or if I put a line up and down, it's a rectangle and a rectangle. Right now, this shape is not a rectangle, right? So it doesn't matter which one you choose. This is the first way I looked at splitting it. So I'm going to split it like this. Now all we have to do is find the area of both figures and then add them together. And that's how we get it. So this, the area, remember you multiply length times width to find area. And the figure is 4 by 6. which is 24. So this rectangle that I made is 24 cm squared. And then this figure I made, we have an issue, right? Do you see the issue? The issue is we don't know this side. But we have enough information to find this side. We know this is 3. And we know this right here is the same length as this. And it gets cut off like right here, right? So right here is 2. So if this is 2 right here, then what has to be this? This missing piece, which is the same as this missing piece, which is the same as obviously this piece. The question mark plus 2 equals 6. So the question mark must be 4. And then 4 times 3 is 12. Therefore, this figure has an area of 12 centimeters squared. So we have this is 12 centimeters squared. This is 24 centimeters squared. So the entire thing must be 36 centimeters per square centimeters. It's just all that's so confusing. Okay, it is a little bit confusing, and it's okay that it's confusing. What's important is this guy represents, I have no idea what my name is, let alone the math. This guy represents, I am the smartest, most intelligent human being in the entire world, even though Mr. Stahl drew me and I look like a pig nose. Now, every single one of us is somewhere between this guy, because he's impossibly low, and this guy who's impossibly high. The idea is every day in math, wherever you are, you just move up, even if it's the smallest bit. So do not get frustrated if you have not mastered this by watching my explanation for 2 minutes. That's okay. The idea is you were exposed to it and you moved up just a tiny bit. Let's get into today's work, shall we? Today we are going to work on Battleship. No, I'm just kidding. We're not really working on Battleship. Today what we are going to do is we are going to work with the coordinate plane. This is not the coordinate plane. This is an example of Battleship. But if you ever played Battleship, you are good, man. You are so close to understanding this coordinate plane. Let me kind of show you what I mean. First, let's talk about the vocabulary words. We have the coordinate plane, we have ordered pair, we have the line of origin, we have the x-axis, the x-coordinate, the y-axis, and the y-coordinate. Well, oops. Let's look at a real coordinate plane before we can discuss these vocabulary words. The first vocabulary word is x-axis. That's the one I want to look at first, and y-axis and coordinate plane. So the coordinate plane is literally this graph right here. You know, yesterday we were talking about like patterns, and we said x and how it compares to y. Well, now, like yesterday, I think one of the examples was x times 2 equals y. Now we could plot all those patterns on a coordinate grid, and I'll show you how to do that, or a coordinate plane. Now the x-axis is this line. It represents how far over you go. This right here is the line of origin, 0. This is where you always start before you graph and you plot these points. So you go over, which is x. This is the x-axis. Some people call it horizontal, which means it goes left to right. And then you go up and down, or called vertical, and the vertical is the y-axis, okay? So left to right, x-axis, up and down, y-axis. So every plot, or every point is plotted somewhere over and up, and then you make your dot, and you can describe where that dot is because you can say, oh, it's 8 over and 5 up, or oh, it's 4 over and 1 up, or oh, it's 1 over and 2 up. Well, instead of saying over, you say, the first number that you say is the x number, and the second number you say is the y number. Let's look at And the reason I put battleship here is because it is an awesome example of something that's so similar to the coordinate plane. All right, so a coordinate plane is formed by the intersection of a horizontal number line called the x-axis and a vertical number line called the y-axis. An ordered pair is used to describe the location of any point in the coordinate plane. For example, the ordered pair, which is 9, 5, describes the location of A. Well, how do we know that? We don't see A. Well, let me show you where A is. A would be 9, so it's 9, 5. So that means 9 over, 5 up. 1, 2, 3, 4, 5. So then I'd put this here, and I'd put the letter A next to it. And that tells me that's where A is. 9 over 5 up. An ordered pair consists of an x coordinate and a y. The first number that you see is the x. The second number is 5. Oops. All right. So what I was hoping to get to was this plane right here. The plane helps me describe to students kind of how you put these numbers down or how you plot your points. So let's go back to that 9, 5 for A, right? So if you think about an airplane starting here, an airplane is not a helicopter. It will not go up first. Before an airplane can go up, it's got to go over, right? So I always think the first number is how far over. So the airplane goes this way, 9. And then the second number is how far up, 1, 2, 3, 4, 5. So that is how we can plot A right there. So it says, let's work on some of these together. Let's work on some of these together right now. Have your book open, write down these answers. Here we go. It says, an ordered pair is used to describe the location of any point in the coordinate plane. For example, an ordered pair of 9, 5 describes the location of the point on A. An ordered pair consists of the x coordinate and the y coordinate. The first coordinate and the x coordinate represents the distance along which axis? X. The second coordinate, the y coordinate, represents along which axis? The y. And that says the origin of the coordinate plane is the point at 0, 0. Why is the origin an important point? Well, here's the origin, 0 over, 0 up. Why? Because that's where everything starts. It's where everything originates. Hence the word origin, okay? That's where everything starts or begins. Let's rock these odds together. B, write an ordered pair to represent B. Well, the way you write an ordered pair is you put your parentheses here, and then the first number you say and your second number gets separated by a comma, and the first number you say how far over it is. So the first, we're looking at point B. Point B is 3 over, and point B is 3 up. So its coordinates are 3, 3. You guys ever have like a treasure map and you have like an X in like your backyard or something, and you're telling someone how to find the X, and you say, take 3 steps over this way, take 4 bunny hops this way. It's kind of like that, right? We're showing someone on the grid how to get to your point. Let's look at D, number 5. Try that one out and then check it with me. Well, if you did it correctly, you said 8 over, 1 up. So point D is 8, 1. Let's try 7. 7 is M. If you did M correctly, you said M is 6 over, right? 5 up. And then let's look at R. R would be 2 over and 6 up. The first number you tell them is how far over. Second number is how far up. And that is how you write an ordered pair to represent the location of a point. Let's go to the next portion. Let's still rock those odds, all right? Here we go. Point J, and this is how you actually plot a point on the coordinate grid. It's telling us put point J at 5, 4. Well, the first number is over, second number is up. Make your dot right at that cross section. Some people like to put it like in the center, or they like to put the letter there. The letter's not important, the dot is. And then anywhere next to the dot, you can label it. Y would be 2 over, 0 up. Ooh, those are tricky ones. K would be 4 over, 5 up. For the record, let's go East. Thanks for watching. Thanks for rocking your math. B, I didn't do B yet, right? 6 over, 1 up. 6 over, 1 up. B. 10 over, 0 up. And you could imagine where people usually go wrong, right? People usually go wrong because they'll flip-flop them and accidentally go up first and then think that the next number is over. Don't make that mistake, okay? First number tells you, just like an airplane, how far to go over and then how far to go up. 10 over, 0 up, and then C would be 0 over, 6 up. 0 over, 6 up, bada bing, bada boom. Let me label that bad boy. There you go. It's as simple as that. I hope you're saying it's simple right now. That'd be great. And then they want us to also, on the coordinate plane, draw an angle of the given type. The angle should have its vertex at one label point and sides that pass through 2 other label points. Give the names for the angle. All right, I should not have erased that. Maybe we will rock this together during the live session on top of rocking the odds together. So I will see you at 10:30.